Next topic, effect of substituents on the acidity of carboxylic acid. First one, electron releasing alkyl group decreases the acidity. Here one comparison is given, formic acid, acetic acid, propionic acid. Formic acid is only having greater strength compared to acetic acid and propionic acids. So formic acid is only having greater acidity character. That means formic acid only can donate more number of H plus, because see this three structure, instead of hydrogen here one alkyl, that is methyl group is there, instead of hydrogen here ethyl group is there. So in both compound, instead of hydrogen alkyl group only present. Generally alkyl group having the tendency to donate the electrons. Alkyl groups having the tendency to donate the electrons. So if CH3 donate electron means that electron moves towards to carbon. So automatically this bonding electron also move towards to oxygen, and the bond which is present between oxygen and hydrogen, in that bond also electron moves to hydrogen. So the bond strength increases because of alkyl group. So compared to formic acid, it can break lesser number of bond only, so it can donate lesser number of H plus only. Compared to this, comparing acetic acid and propionic acid, this is the big alkyl group, because this alkyl group contains only one carbon, but this alkyl group contains two carbon. So it can donate more number of electrons to this carbon, means here also the bond shifting takes place. So here also bond strengthening takes place. So bond is present between oxygen and hydrogen, that is also, in that bond also strength is increases. In strength is increases means that bond, that compound can donate only very less number of H plus compared to acetic acid, so only acidity characters decreases. So the electron releasing group, that is plus I group. I means inductive effect, positive inductive effect. That means here electron is moves to one direction, that is called as plus I group. So increase the negative charge on the carboxylate ion. Because of electron transferring, the negative charge on the carboxylate ion increases and destabilize it, and hence the loss of proton becomes difficult. For example, formic acid is more stronger than acetic acid and propionic acids. Electron withdrawing substituents increases the acidity. In this heading also one order is given, acidity order is given. See this order, all are acetic acids only. CH3COOH, in CH3COOH one hydrogen is replaced by fluorine. In this compound, in acetic acid, one hydrogen is replaced by Cl. Like that, one hydrogen is replaced by bromine, one hydrogen is replaced by iodine. Among this compound, this is having greater acidity because the electron attracting tendency, all are halogen, fluorine, chlorine, bromine, iodine, all are high electronegativity atom. Compared to other three, fluorine is a high electronegative atom, so it can attract the electrons powerfully. So if it attract the electrons powerfully means electron move towards to fluorine, so automatically this bonding electron move towards to carbon, so automatically the bond is present between O bond to H. This bonding electron also move towards to oxygen, so the bond is break, which bond is present, that is bond is present between oxygen and hydrogen, that bond will break and it will produce more number of H plus compared to Cl, Br, iodine. Because this is the high electronegativity atom, it is having more tendency to attract the electron. So compared to all other three, in this compound only the electron movement is greater. So here only the bond cleavage is more, so only it can give more number of H plus compared to other three. So, the electron withdrawing substituents decrease the negative charge on the carboxylate ion and destabilize it. So, because of electron withdrawing group like fluorine, chlorine, bromine, iodine, so decreases the negative charge. So, carboxylate ion stabilize it, and in such case the loss of proton becomes relatively easy. Acidity increases with increasing the electronegativity. Electronegativity increases means compared to iodine, bromine is having high electronegativity. Compared to bromine, chlorine is having high electronegativity. Compared to chlorine, fluorine is a high electronegativity. So, electronegativity increases means acidity character also increases. For example, the acidity of various halona means halogen, fluorine, chlorine, bromine, iodine. Haloacetic acids follows this order. Acidity increases with the increase in number of electron withdrawing substituent. Acidity increases when increasing number of electron withdrawing substituent on the alpha carbon. See here in this compound, this is functional group. Next to the functional group is called as alpha. At alpha, 3 electron withdrawing group is there. Here at alpha position, 2 electron withdrawing groups are there. At alpha position, only 1 electron withdrawing group is there. At alpha position, there is no electron withdrawing group is there. If number of electron withdrawing group is more on the alpha carbon means acidity increases, because it will attract more number of electron means it will break more number of bond between O and H, so it can give more number of H plus. That's all. So, the effect of various electron withdrawing group on the acidity of carboxylic acid. So, NO2 is a powerful withdrawing group compared to cyanide, and this is the decreasing order after fluorine, chlorine, bromine, iodine and phenyl group. The relative acidity of various organic compounds are, among these compounds, different compounds, carboxylic acid having only more acidic character than phenol, water, alcohol and alkyne. Next one, functional derivatives of carboxylic acid. Functional derivatives of carboxylic acid means in RCOOH, that is carboxylic acid, in RCOOH, that OH group is replaced by Cl means you will get acid chloride. In RCOOH, that OH group is replaced by NH2 means that you will get acid amide. In RCOOH, that OH group is replaced by OR means you will get ester. In carboxylic acid or COOH, OH group is replaced by OCOR. OCOR means you will get acid anhydride. So, one example is given. So, from acid we can derive these 4 compounds. So, that is called as functional derivatives of carboxylic acids. So, compounds such as acid chloride, amide, ester and acid anhydride are called as carboxylic derivatives because they differ from the carboxylic acid only in the nature of group or atom that has replaced OH group of carboxylic acids. All these 4 compounds are obtained by replacing OH group by this substituent. This is called as functional derivatives of carboxylic acids. Relative strength of relative reactivity of acid derivatives. So, some comparison is given. RCOCl, acid chloride having more reactivity than acid anhydride, than ester, than amide. So, the above order of the reactivity can be explained in terms of 2 points, that is, one is basicity of leaving group, another one resonance effect. First one we are going to learn basicity of leaving group. Weak base or good leaving groups, hence acyl derivatives with weak base as leaving groups can easily rupture the bond and more reactive. So, weaker base means good leaving group. Acyl derivatives, this is acyl derivatives with weaker base as a leaving group can easily rupture the bond, so more reactive. So correct order of the basicity is, which one is having more basic character NH2, which one is having least basic character Cl. Weak bases are good leaving group, so only this weak base Cl minus act as a good leaving group, so it can rupture the bond and remove from this compound easily, means this is reactivity increases, the compound reactivity increases, so only this compound having more reactivity. So from the basicity we can understand this point. This is having basicity more basic character, that is more basic means poor leaving group. Poor leaving group means in this compound this bond is not cleaved easily, so it can give very less number of H plus. Next point, resonance effect. Lesser the electronegativity of the group, greater would be the resonance stabilization. Lesser the electronegativity of the group, so less electronegativity atom is present in the compound, means greater would be the resonance stabilization. Resonance stabilization means what? This electron moving, this atom donating this lone pair and moves here and form one bond, means automatically this bond comes out and form O minus. That minus moves here, double bond, means automatically this bond comes out and form lone pair. So less electronegativity group means greater would be the resonance. So this effect makes the molecules more stable. Usually resonance involved means that molecule is more stable. Example, benzene. Molecules more stable means reduces the reactivity. Yes, stable compound won't react. Unstable compound only react and try to attain the stable state. So more stable compound reduces means reduces the reactivity of the acyl compound. So this effect, this resonance effect makes molecules more stable. So automatically reactivity reduces. The order of the electronegativity of the leaving groups of the following order. Already you know, this is a good leaving group. After that OCOR, OR, NH2. Hence the order of the reactivity of acid derivatives with nucleophilic reagent. The reactivity is which one? Acid halide, that one having more reactivity. Next one acid anhydride, next one ester, next one amide. So the same point only.